Let's learn how to do the 13th problem. The question is, how many 3-digit numbers are divisible by 7? Now, first, let us try to list down the terms of the AP. So, before getting into 3-digit numbers that are divisible by 7, what are the 3-digit numbers? So, we know the 3-digit numbers start from 100, 101, and we have it till 999. So, but this is not the required AP. Within this range, which are the numbers, which are the 3-digit numbers which are divisible by 7? So, whatever I've written on the screen, they are the 3-digit numbers starting from 100 till 999. This is the range of 3-digit numbers we have. But within this, what are the numbers that are divisible by 7? So how do we do this? So there are some methods in which we can do this. So I'm taking 100 and I'm dividing it by 7. So the question is divisibility by 7. So when I just do the non-decimal division, which means I stop with this. So you can see. I'm stopping with this. I'm not taking the decimal part. So we know 17 4 times you get something, and then with that it stops. So when we subtract this remainder from 100, we get 98. So we understand that 98 is a number which is divisible by 7. So basically you take the starting number and you divide it by 7. If you get 0 as the remainder, then you know that 100 is divisible by 7. Here we are getting a remainder as 2. So when we subtract the 2 from the dividend, we get 98. So we understand 98 is a number that is divisible by 7. But it is not a 3-digit number. So when you add 7 to this, you get 105. So thereby you understand that 105 is the first 3-digit number that is divisible by 7. So this is how we get the first term. And then again you add 7, you get 112. Again you add 7, you get 119. So this is the starting of the AP. So very similar to that, we need to find the last term of the AP. So how do we do it? Very similar. So we take 999 and we divide it by 7. So the same way I'm doing the division, as you all can see. So now we get the remainder as 5. Before getting into the decimal part, we get the remainder as 5. Again, this 5 should be subtracted from 999. So you get 994, and that will be the last term of this AP. So this blue color thing is actually the required AP and not the red color one. So with this idea, we are going to start the problem. So though the 3-digit numbers are from 100 to 999, we kind of find the numbers which are divisible by 7, and that we do by just dividing them in the rough column and then subtracting, then you get the actual numbers. So now we are supposed to find how many of these are there, like 105, 112, 119. So till 994, how many numbers are there? So how we do this? We consider 994 as AN because that is the last term. And then we use the formula, which is A plus N minus 1 into D is equal to 994. So here A is the first term, which is 105. And N is what we have to find out. Like how many 3-digit numbers are divisible by 7. So N is what we have to find out. Common difference is 7. That's quite obvious because all of them are divisible by 7. And the difference is also 7. If you see 112 minus 105 is 7. So you'll be getting 994. Now, N minus 1 times 7 will be 994 minus 105. So we will be getting 889, and then the next step will be N minus 1 equals 889 divided by 7. So 7 1 times is 7, and then you have 18. 7 2 times is 14, and then you have 49. So 7 7 times. So finally you are having N minus 1 equals 127. So you'll be having N equals 128. So the final answer is 128 3-digit numbers are divisible by 7. When it comes to 14th question, it's quite easier than the previous question because here the multiples, they have asked for multiples of 4. So the range that they have given is from 10 until 250. So within this range, what are the numbers that are divisible by 4? So we know after 10, the first number that is divisible by 4 is 12. So we know that. So and then the next number is 16, and then 20, and so on. And we also know that the last number would be 248. So the range is from 10 to 250. They have asked for multiples of 4. Multiples of 4 in the sense 4 1 times, 4 2 times, 4 3 times, all that, the tables thing. So after 10, so though the first two multiples of 4 are 4 and 8, we don't have 4 and 8 after 10. So after 10, the first number that is divisible by 4 is 12. And then the next number you will get by adding 4, 16, 20, and so on. And the last number will be 248. If you don't know the last number is 248, then what do? You take 250, which is the last number in the range, you can see here. And then like how we divided it by 7 in the previous problem, we divide it by 4. Then you do the normal division. So now you can see the remainder is 2. Then you subtract that remainder from 250. So you'll be getting 248. So if you get the remainder 2 for 250, it means that it is not perfectly divisible. So you subtract that number and you get 240. So that is how we get this AP. This is not as difficult as the previous problem. So, but we are trying to figure out the AP. This is called an AP. And then how many multiples of 4 lie between? We are supposed to find the n value. Like how many numbers are there till 248? Very similar to the previous problem. We take 248 as an and then we find the value of n. So then we assume an as 248 because that is the nth term or the last term, and then you substitute a plus n minus 1 into d is equal to 248. A is 12, n minus 1 into the value of common difference is 4. It's very obvious, equals 248, and then n minus 1 into 4 is equal to, so we get this as 236 on subtraction. Did you all get this? So n minus 1 equals 236 divided by 4. So here you will be getting, so this will be 5 times, and then so 4 5 times is 20, and then you have 3 6 9 4 9s are, so n minus 1 equal to 59 and n equals 60. So the answer is there are totally 60 numbers that are divisible by 4 or multiples of 4 between 10 and 250. When it comes to the 15th problem, they're asking for what value of n are the nth terms of the two APs equal. So there are two APs that are given. So first one is 63, 65, 67, and so on. So this is the first AP. And also they have given one more AP, which is 3, 10, 17, and so on. They have given two different APs. They are different to the extent. Common difference is that is also different. First term is also different. In the first AP, the first term is 63. In the second AP, the first term is 3. In the first AP, the common difference is 2. In the second AP, the common difference is 7. Now, what they have given is nth terms of the two APs are equal, and we are supposed to find the value of n. So when we say nth term, we talk about an. So an will be a plus n minus 1 into d. So this is something we all know and familiar with. So 63 plus n minus, we don't know the value of n. D is 2. The value of a is 63. The value of d is 2. So this will become 63 plus 2n minus 2. Now you take this 2 and multiply it with the things in the bracket. That's all you can do. You can't do anything. And of course, you can do one more step, which is 61 plus 2n. So now 63 minus 2 will become 61, and the 2n will remain. Likewise, even for the second term, second AP, we are finding an equals a plus n minus 1 into d. And a is 3, n minus 1, we keep it as n minus 1, d is 7. So likewise, we take this inside, so 7n minus 7. So here we get it as 7n minus 4, because 3 minus 7 is minus 4, larger number. Now we equate both of them, because in the question they have given nth terms are equal. That is the last step. Since nth terms are equal, we know that the nth terms are equal. So since the nth terms are equal, we can equate both the nth terms. That is 61 plus 2n and 7n minus 4. Now when 2n goes to this side, it becomes 5n. It gets subtracted, and when minus 4 comes here, it becomes 65. And then n equals 65 divided by 5. We get n equal to 30. So this is something that we need to do. Let's learn 16th problem. We are going to find the AP. which means we have to find the first term and the common difference and therefore generate the AP. They have very clearly given the third term is 16, which means A3 is 16. And they have also given seventh term exceeds the fifth term by 12. They have given third term is 16, which means A3 is 16. And they have given seventh term exceeds the fifth term, which means A7 is 12 greater than A5, which means when you subtract A7 and A5, you will get 12. Or you can also write it like this. A7 is A5 plus 12. We can also, both are the same. So wherever we get exceeds, it can be written like A7, seventh term exceeds in the same subtraction, fifth term by 12. So this is what we have. Now, third term is nothing but A plus 2D. This we already know. So we get an equation. A plus 2D is equal to 16. Whereas here we have to substitute A plus 6D minus A5 is A plus 4D. We all know this, which will be equal to 12. Now in the next step, we have A plus 6D minus A minus 4D equal to 12. Now A and minus A will get cancelled. So we get 2D equal to 12 and D equals 6. Now we substitute this value of D in the first equation. So we get A plus 2 times 6 is equal to 16. We get A plus 12 is equal to 16 and therefore A is equal to 4. So we get A value as 4 and D value as 6. And finally, we know the first term is 4 and common difference is 6. So when we add 6, we get 10. Again, we add 6, we get 16 and so on. So this is the required A. 17th problem. There are two ways of doing this, but we look at one of the methods now. So find the 20th term from the last. So basically, they have given an AP 3, 8, 13 and so on till 253. So if you come 20 terms from the 250 from the last term, which is 253, what will be that particular term from the end? So it's quite easy when we kind of reverse this. So what I'm going to do is I'm going to reverse the AP. So I'm going to take 253 as the first term and I'm going to completely reverse this. 13, 8 and 3. So if you look at what I've done, I have completely changed the order of this AP. So they have given 3, 8 and so on till 253. I'm writing it in the reverse order, which is 253 and so on till 13, 8 and 3. They have given it in increasing order. I'm making it as the opposite decreasing order. Now for the given AP, whatever they have given, the common difference is 5. If you look at it. Then for the reverse AP, the common difference will be minus 5. Because here we don't know the next term. If you see here, in the AP that they have given, it is easy to find the common difference. You can see 8 minus 3 is 5. 13 minus 8 is 5. But in the reverse AP, we only have one term in the beginning. So how do you find the common difference? In the original AP, if the common difference is 5, then in the reverse AP, the common difference will be minus 5. So here we take this as A and the common difference as minus 5. You can do like that, or you can also look at the last terms and see the common difference. Common difference is not the difference between the second and the first term. It can be the difference between any two consecutive terms. So when you do 8 minus 13, you get minus 5. If you look at the screen, when you do 3 minus 8, you get minus 5. So the common difference is minus 5 after reversing it. So if it is 20th term from the last term, after reversing, it is the 20th term from the first term. So you directly calculate A20. So you will be getting A plus 19D. Here A is 253 and 19 times D is minus 5. So we get 253 minus 90. Sorry, just a minute. Minus 95. So this will be 158 and this is the answer.